This is Geometry Semester 2. This is the third unit called Solids. This is the sixth lesson called Volume of Hexagonal Prisms and Slant Hexagonal Prisms Practice. It's on creatormath.com under the Geometry tab. Copy of the following problems 1 through 4. Only those you have to copy into your composition book on the correct pages according to the table of contents with the notes for those pages. Remember, these are the problems I'm doing. You also need the notes in your comp book. That's a separate file under that table of contents on creatormath.com under the Geometry tab. So this looks a little bit more complicated, but you're going to see a pattern. The pattern that will emerge we'll talk about right here. Given the following three-dimensional shape, what is the volume? Hint, the volume of a hexagonal prism is 3 times the square root of 3 divided by 2 times the side length of the hexagon squared times the perpendicular height. All right? So let's see if we can pull up even that one on the screen, right? Just Google volume of hexagonal prism, right? And it'll pop up right away if you don't like the way that my formula is playing out here, right? So here's what we've got. Volume equals 3 times the square root of 3 divided by 2 times a squared times the perpendicular height. I'm going to say perp height here because we want to make sure it's the perpendicular height. They show it over here. Let's bring this back up top. There we go. Perpendicular height. And so this is 3 times the square root of 3 divided by 2 times the side length of the hexagon squared to the power 2 times the perpendicular height. So this is a little bit hard to read. Help yourself out if you can't figure it out. Remember, this is not the only source, right? And it even says, look, oh, this is nice. Hint, Google, quote, how to calculate the area of a hexagon to get the calculator to help you. You can do that for part of it. Now, that's just area, but I think it might actually have a calculator for volume 2 by now. The length of the side of the hexagon is 1 inch, and the perpendicular height is 10 inches. So now, for this particular one, this piece here, which is called A, is 1 inch. 1 inch, that's this one. The length of the side of the hexagon is 1 inch, and the perpendicular height equals 10 inches. And we're in inches. So let's go ahead and say 3 times square root of 3, come on, 3 over 2, times 1 inch squared. Go ahead and put in 1 inch squared, put in the unit, times the perpendicular height of 10 inches. V equals this again, 3 radical 3 over 2. 1 squared is 1, so this is times 1. Inches squared is inches squared. This is times 10 inches. So here's the calculation part. 3 times 10, let's make this 30. Keep the radical 3 over 2 in there. 1 times all that, so that disappears. Inch squared times inch is inch cubed, right? Because there's a power here and a power there, and you add them, it goes to 3. And now it looks like they're giving us an approximate value. So go to your calculator. Make sure to turn your calculator horizontal and don't have your lock on or it won't shift. And let's type this in. Let's do 30 times square root of 3. I'm going to put a parentheses to box that in. And I'm going to say divided by 2. So I get 25.98 inches cubed. All right? And here it is, 26. So approximately 26 inches cubed. That's approximately 26 to me. All right? And look at the other answer choices. They're way off. So as long as I'm getting close to this sucker, I've got the right answer. Let's repeat the whole thing. The question looks the same to me, right? Given the following shape, hint, here's the prism. Its volume equals 3 radical 3 over 2 times a squared times the perpendicular height. V equals 3 times radical 3 over 2. What is the length of the side of the hexagon? Looks like 2 inches, right? They're being very gentle with us. I appreciate that. So 2 inches squared times the perpendicular height of 10 inches. And so that A is the length of this side here. That's what A is right there. And I'm sorry I used A because it starts to look like a 9. Times the perpendicular height of 10 inches. 10 inches. V equals 3, radical 3 over 2 times 2 squared is 4. Inches squared is inches squared. Still times 10 inches. Let's do them separately on this one. We may combine them later. 4 times 3 is 12. 12 divided by 2 is 6. 3 times 4 is 12. Divided by 2 is 6. You still have a radical 3 in there, or square root of 3. Same thing. Times 10, which would give us, well, I better do it in a separate step, just since I went down this road. 6 times 10 is 60. Radical 3. I have my 10 inches, but I dropped this, squeeze this in down here. Inches squared, because we want to check our units. Inches squared times inches to the 1 power is inches cubed. That's a good sign. They're asking me to go ahead and drop this into my calculator. Let's back this out. Clear. 60 radical 3. 60, and that's a times between there. 60 times square root of 3. It says it's giving me 103.92. I better make this an approximately equal to, because I'm truncating all those digits or cutting off. That means I'm less accurate, so I better say approximately equal 103.9 approximately. And it says inches cubed. Let me make sure I'm on board with that, which I am. And go to the next one. So now we're to an oblique shape, otherwise, kind of conversationally called a slant shape, right? But oblique is the proper name. Oblique is spelled oblique. And when I was a student, I was tempted to say oblique, but it's pronounced oblique. Same formula, you guys. Just got to make sure and use the perpendicular height here. Perpendicular means 90 degrees to the base or ground. And it's the same thing we use for an altitude of an airplane. You straight up from the ground, right, being perpendicular to the ground. So volume equals 3 times the square root of 3. 3 times the square root of 3 over 2 times A squared times the perpendicular height. V equals 3 square root of 3 over 2. A. In this case, they say the length of the side of the hexagon is 1 centimeter. So this here is 1 cm. Let's put this 1 cm into the A and square it. Square both the number and the unit. Times perpendicular height. Perpendicular height is 10 cms. 10 cms. Volume equals 3 radical 3 over 2. 1 squared is 1. Centimeter squared is centimeter squared. Times 10 centimeters. Volume equals, can I combine some things here? It's 1 times 10. 10 times 3 is 30. Divided by 2 is 15. 15 radical 3. A centimeter squared times a centimeter to the 1 power is centimeters cubed. Volume equals, looks like we're going to use our calculator again. Interesting, on some we just leave it pi, some we use our calculator. That's good because we get a variety of practice. Times square root of 3. Okay, looks like 25.98 cm cubed. I better make this approximately equal because I'm cutting off all of these decimal places, right? It's called truncating, cutting them off. And it says approximately 26 centimeters cubed. That's the correct answer. All right, one more. Also oblique. Not oblique, but oblique. There it is right there. An oblique hexagonal prism. Right? We want to know the volume. V equals 3 radical 3. They tell us right here. They keep telling us every time, so you don't have to memorize these. 3 radical 3 over 2 times A squared times perpendicular height. Perp height. All right, so V equals 3 radical 3 over 2. Let's see what A is. The length of the side of a hexagon is 2 centimeters. That's here, 2 cm. So that goes drop 2 cm into both these. Perp height, 90 degrees to the base. 10 centimeters. They've been very gentle on the computation here. We still need a calculator anyway, so these could be decimals or anything. It could be a lot more complicated, but I appreciate that they're just going for the basics. 2 squared is 4. Centimeters squared is centimeters squared times 10 centimeters. What can we multiply? 3 times 4 is 12. Divided by 2 is 6. Times 10 is 60. You still got a radical 3 in there. You still got a centimeter squared times a centimeter to 1, or centimeters cubed. 60 radical 3 centimeters cubed. Let's see what we've got. Clear. 60 radical 3. Ooh, I like, I'm in the right direction here. 103.92. Let's make it approximately equal. Keep our units centimeter cubed. And come over here, 103.9 centimeters cubed. I think the most interesting thing to me, if I was a student, I don't need to be confused by a slanted shape like this. It's the exact same volume formula and the exact same application, as long as we don't get confused by this length. Sometimes they'll give you this length, right? Instead of saying just perpendicular height is 10, they'll tell you this is whatever it comes out to be for this angle. I don't know, say it's 12, right? And students will be tempted to use 12 for the height. If you can remember that part, oblique and hexagonal prisms that are just straight up and down, right, 90 degrees, and oblique ones have the same volume calculation as long as you're using perpendicular height. Again, this is on creatormath.com, and it's under the geometry tab. Make sure you're matching up the exact title of these problem sets with the problem sets you're doing in your School G work.